Okay, so in today's discussion, what we are going to do is covalent bonding. Earlier, we had discussed that ionic bonding is something that was relatable to like ability to transfer electrons from positively charged group to the negative one, and that was applying some sort of like that was producing cation and anions. Now, the next topic is going to be covalent bonding. What a covalent bonding is? A covalent bonding is something in which there is sharing of electrons between two groups. Generally, the sharing takes place among non-metals. So when two non-metals are going to share their electrons, this is called as covalent bonding. You should be clear how different things are going to share their electrons. They share their electron due to the presence of electronegativity gaps between two non-metals. So when there is a electronegativity difference between two non-metallic groups or two non-metallic elements, they are going to share like the electrons. So generally that sharing is like it is attracted more towards that side, that element who is more electronegative than that of one who is least electronegativity. Now there is two comparison between ionic and covalent. Ionic was transformation and covalent is sharing. Other thing was that that was consisting of electronegativity difference between elements. I mean, like when the positive was the donor of electrons, so you are not going to use the word of donation is in this thing. Why? Because you have to use sharing of electron between two non-metallic groups between them. Now, what is available right there? The simplest point is that these are going to simply okay. Now, in any bond, the particles are held together by electrostatic attractions between something positively charged and something negatively charged. So, obviously, we cannot allot them like a general positive and negative charge, but we allot them these charges on the basis of their electronegativity differences. Okay, when it comes to the covalent bond, that is something in which a pair of electron is shared when pair of electrons is shared between two atoms. So when two atoms share a pair of electron between them, this is called as covalent bonding. They hold, okay, what holds the atom together is strong electrostatic attraction between the nuclei, which is generally positive charge of an atom that makes up the bond to the negatively charged electrons. Now, there is a twist in this thing. What they're trying to say is that these things are going to attract positively charged. So that let's say this is hydrogen. Generally, in water, there is polar covalent bond. So what they're saying is that when there is a bonding between water and I mean, like when there's a bonding between the water's hydrogen and chlorine of salt, or even let's make it oxygen. Now, oxygen is negatively charged. So they are saying that electron of negatively charged group will attract the or will it will develop electrostatic attraction between nuclei and outermost electron of an element. So you should be clear that positively charged nuclei is going to attract the negatively charged electron of an element. So simply it is generally attraction between nuclei and negatively charged electron of an element. So the other thing is going to be okay, so this is the way they are. Simply, there's an element A whose nucleus, which is positively charged. This is made up of proton and neutron. Now, nucleus of an element A would be attracted to the electron pair who is negatively charged. So B was already negative. The electron present in the outermost shell of B or outermost shell of the B element that will attract positive charge of the nucleus. So that is how they're going to make this attraction possible. Okay, so next thing is going to be the clay car example. Another thing or twist you could say that is that they are going to have this attraction is going to be present between the diatomic molecules. What the diatomic molecules are? Diatomic molecules are when two hydrogen atoms, or when two same groups are, or when two non-metallic atoms are going to be bonded with each other. Now, hydrogen atoms form diatomic molecules with this formulae, and the atoms in an hydrogen molecules are joined together by covalent bonding. Now, this covalent bonding present between two hydrogen atoms is very strong. Why? Because for some really, I mean, like less than that phenomena where it takes place, you could say that for a millisecond, one of them would attain positive charge, other would attain partial negative charge. In this case, one would be giving on, you could say that he's going to make a distance from its electron, and other guy is going to attract that electron. Okay, then they would repeat this activity. So that is how they're going to make this thing possible. Okay, now molecules contain a certain fixed number of atoms which are joined together by the covalent bond. Now, when it comes to hydrogen, is a diatomic molecule because they contain two atoms who are really joined together, and other sorts of molecules may have as many or thousands of atoms joined together. For example, your DNA. See, in your DNA, trillions of carbon atoms are joined together to give rise to your DNA. Also, when it comes to body skeleton is made up of carbon. I mean, like trillions of carbons are united or linked together to give rise to covalent bonding. Next thing is going to be what they are trying to say is that they are going to attract each other due to the presence of I mean, like some of them will be sharing electron by like all of them will be sharing electron generally. Now, okay, next thing is going to be what is the significance of the gas structures in the covalent bonding. So when it comes to hydrogen atoms, it has only one electron to share. So it can only create one covalent bond. Now, simply when you are going to make a bonding between two hydrogen atoms, when you are going to bonding between two hydrogen atoms, they are going to give rise to the diatomic molecules. Now they share pair of electron in the outer shell of both. So basically both contain one electron in their outermost shell, and then they are going to share that electron with each other. Okay. Now the next ideology is that okay. So does that mean that hydrogen has turned into helium? No, that is not possible. Now, what they're saying is that the number of protons in the nucleus hasn't changed. It is the number of protons that defines what an atom is. Definitely, if something contains six protons in its outermost shell, we can say that okay, this is carbon. When it contains protons in its in its nucleus, sorry, it would be the nitrogen. Now, what they're saying is that generally, what why noble gases are important because noble gases are considered to be a standard of stability. Now, everything have a relativity or standard when we consider that noble gases are standard of stability because they are stable. Their outermost shell is called as like the outermost shell is following octet rule because they are stable in nature. So we just made them stable basically. Now, in virtually all the molecules you met at this level, that their electrons will be shared so that the H atoms or hydrogen atoms have a total number of two electrons in their outermost shell in their with, and all other atom will have eight in their outermost electrons. So simply this called as the octet. Why? Because when number of eight electrons are present in outermost shell of an atom, it means that outermost shell is stable. However, stability is relatable to even number of electrons. It could be sorry, it could be two, four, six, eight, even 10 is possible. But there were two general rules were given, or you could say the general laws were given If we say that that is an octet rule, it means that something is made standard whose outermost shell is containing 8 electrons in it. Okay, so simply, what I'm trying to say is that noble gases are considered as an octet rule standard. Why? Because their outermost shell contain 8 electrons, and that is a rule, that is a standard of stability. So simply, when there is one atom in the middle and other atoms are joined, such as methyl or phosphorus trichloride in the outermost atom, will eventually always have 8 electron in their outermost shell. It could be two or something. So, in fact, it is a very difficult to think of an example where outermost atoms do not have 8 electrons. Now, there are some molecules where center atom does not have 8 electron in the outermost shell. So, there are certain examples available. Why? Because it is not mandatory to have exact 8 numbers. That is simply a level of stability. That that stability that stability That stability is relatable to even number of electron. However, if we make noble gas as a standard, so there should be an 8 number of available electron in their outermost shell, so that we could follow that they are making octet rule to be followed up. Okay. Next thing is going to be, why does hydrogen form molecule? Whenever a bonding is form of any kind, whenever a bonding is created or produced, that makes that the hydrogen involved is more stable. Okay, the things involved are more stable as of earlier. Obviously, if we consider that sodium is going to make one bond with the chlorine atom, however, okay, let us take. Okay, here's my pencil. So what they are trying to say is that uh, things were earlier unstable. When they create the bonds, they got stabilized. So simply, why hydrogen? Simply things create bonds to attain the stability. If we consider hydrogen chloride or HCl, it is simply the result of the polar covalent bond by it creating polar covalent bond. Simply chlorine in its outermost shell, it has total number of 17 electrons. Now, there are two ways of it to attain even number of electrons. It could donate one, it could accept one. Definitely, it is an even number. It is a non-matter is going to except the electron. However, when it comes to proton, obviously it has one. Either it should be two, either it should be zero. So he feels safe to share the one with this chlorine. So definitely after being sharing electrons, both of them will make a, like you could say that, electrostatic contract to attain the stability. So both will got stable. Now, the more bonds an atom can create, the more energy is released, and the more stable the system would be. Now, the hydrogen molecule is much more stable than the two separate hydrogen atoms. Why? Because earlier they were containing odd numbers, but as soon as they create this bond, they both them will attain the stability. Okay, so here's a key point in chemistry when we talk about things being more stable or less stable. It means that depends upon their state. Either they are in excited state, either they are in their ground state, or what type of bond they are exactly creating. Now, we will be considering what are the actual phenomena in which energy is accepted or released. So generally the lower the energy something has, the more stable it would be. So simply stability is inversely proportional to energy. So the least energy something would have, the more stable it would be. Chemical reaction usually occurs so that something become more stable. Okay, now it will fall onto the floor. So simply when something has less potential energy, it becomes more stable. Okay, so that's how they are. Because when the excessive energy is available, they will make things to keep on moving. They will always keep an atom to got like to stay always in motion and all that. Now, next thing is gonna be right there. So a chlorine atom has 7 electrons. When a chlorine atom has 7 electrons in its outermost shell, by sharing 1 electron with within hydrogen atoms, both atoms will have same number of electron as the nearest hydrogen gas. So basically, chlorine has 7 electron in its outermost shell, and hydrogen has 1 electron in its outermost shell. Again, the idea is same: either donate one or either accept something to attain the even number. Now, when we say that it is creating HCl, it means it is creating a bond which is slightly polar. So it is creating the polar covalent bond. It simply hydrogen is positive, chlorine is negative. So they will be creating a pole. Due to this pole, they will be attracting each other strongly. Okay, now so simply there is a point that only electrons the only electrons in the outermost shell of the chlorine are used in bonding. In examples, you will met up the okay, so let it be. The inner electrons will never got used up. Why? Because mainly bonding is concerned with the outermost shell. When something attains stability by making an interaction with the outermost shell, then why it is going to get involved? Now, um, hmm, so you should be able to label this outermost shell like the way they are creating, they are simply labeling them. The outermost shell is labeling by mentioning that it contains 7 electrons, and this guy only have 1 electron. That is how they are creating this bonding. Next thing would be the chlorine and hydrogen atoms, or chlorine and chlorine bonding will be again both of them have same number of electrons. Their electronegativity values are quite same. So simply when they contain 7 electrons in their outermost shell, when there are seven electrons in their outermost shell, they are going to attain stability by making attraction between two chlorine atoms. So when they attract each other, they are going one of them would be positive, other of them would be negative. So simply positive will be attracting negatively charged chlorine group. So some of them would stay positive, other would be partially negative. Although this phenomena would take place for like for less than a second, but this the transformation will take place. So definitely, this cross is going to show how many electrons are present in this thing, and this dot is going to show number of electrons in this word. However, this thing is going to represent the bonding is like created by these electrons who are right over there. So that this thing. Okay. So now the next point is going to be another type of bonding that exists between uh, methane, ammonia, and water. When it comes to see, there is a thing when you are moving from left side to the right side of the periodic table, the electronegativity increases. So if I am looking to this thing, I can clearly say that when I'm moving from this carbon to oxygen, the electronegativity is increasing. If I create a bond between carbon and nitrogen, or carbon or oxygen, who would be most electronegative? So in that case, carbon would be acting as positively charged somehow. This guy will be acting positively charged, and oxygen will be acting negatively charged. Why? Because electronegativity value of oxygen is comparatively higher. That is why carbon is going to be acting as giver or don or sharer of electron. So oxygen needs 2 electrons, and okay, oxygen needs 2 electrons while carbon can give 4 electrons. Now, when two oxygen atoms are attached with each other, it means the requirement of electron got doubled. So, we could create an CO2 bond between them so that one carbon atom could share up 2 electrons to, like 4 electrons to both of the oxygen atoms. Now, there is another thing when it comes to methane. You should be clear. Okay, so carbon have some interesting behavior. When we create carbons bonding to something, okay, let's say there is carbon. Actually, this is a carbon. So here is carbon. present in the middle of the periodic table, and this hydrogen, and now it is in the okay, nearby there is a oxygen. When you say that carbon is making bonding with hydrogen, in this case, carbon would be acting negatively charged. Why? Because in this case, the electronegativity of carbon is higher than that of hydrogen. That is why carbon will tends to attract electrons from each of the hydrogen, and definitely the attractor will be negatively charged. So we can say that when carbon is making four bonds with hydrogen atoms, carbon is going to act as a negatively charged since its valency is 4. In this time, its valency would be termed as negative 4. So carbon will be attracting electrons of four hydrogen atoms, say 1, 2, 3, and 4. So that is how this bonding is created. Now, these got changed when it is creating something who is more electronegative than that of oxygen. So when it is creating, like least electronegative than that of hydrogen. So in this case, its valency would be positive 4. So when carbon is making bonding with something who is least electronegative than that of the carbon, carbon will be negatively charged. When carbon is making bonding to something who is more electronegative than that of carbon, then it will attain positive charge on it, because in that case it will be creating the transformation of electrons. Okay, now, the second element would be nitrogen. So again, it is C Ni. If you can learn this mnemonic, it is C Ni. So next thing would be nitrogen. Nitrogen is even more electronegative than that of carbon, but least electronegative than that of hydrogen. So nitrogen would be attracting electrons of hydrogens, but there is a bit something new in this case. In this case, it contains three electron pairs, like one is created to this hydrogen, other is created to this one, and third is created to this guy. Now, there is a distinctive attitude of this nitrogen for this guy or this pair of electrons. There it is. So it contains three electron pairs, or it contains um, three bonding electrons, and two lone pairs or two non-bonding electrons are there. Since it is in these electrons are in pair, they cannot be engaged in direct bonding because they are stable. Why? Because they are two. However, they will keep on disturbing the people or the electrons who are present nearby. So due to their disturbance, they are going to change bond angle of bond angle of ammonia. Okay, that is so far. This is simple covalent bond. But as soon as these double bond, now this nitrogen is going to please somebody, okay, calm, accept my two electrons and create a bonding with me so that we could got stabilized. Now it is a condition when nitrogen is sharing both of its electrons. See, earlier, generally in normal bonding, it happens that electrons are shared by, like one electron is shared or transferred from each of the elements. But in this case, nitrogen is willing to share both of its electron to create a bonding which is called as covalent bonding. So when both the non-bonding electron pairs are shared by one common element, this is called as coordinate covalent bonding. Why? Because the electrons are shared by one element to attain the stability on both the sides. So again, I'm repeating, nitrogen is sharing both the electrons, both the lone pair electron to create the bonding. Now, there's another thing, that is water. When it comes to water, simply again, it is not, so remember that it is not ionic bond. Water and HCl, they are polar covalent bond creators. They are not creating ionic bonding. Now, oxygen has 6 electrons in its outermost shell. It will therefore transform to other electron to have 8 electrons in its outermost shell. So simply oxygen needs 2 electrons. There is one O. That is why oxygen will be attracting one electron from both the hydrogen atoms. So they would be creating this covalent bond. Now, there is a point. Um, okay, a molecule. Okay, so next thing would be that is the bonding created or present between one carbon and four hydrogen atoms will always be tetrahedral. What the tetra? See, tetra means four, hedra means simply head. So there is a carbon who is attracted towards four hydrogen atoms. So from all the surroundings. Now, next point would be by understanding the bonding is covalent molecule, it is possible to work out on the shape of the molecule's pair of electrons in the outermost shell of the central atom will be repelling each other, and now they are going to change their shape to the tetrahedral one. So in a methane molecule there are four electron pairs around each central carbon atom, and then carbon is going to make the sharing possible. Okay, so when carbon is creating four bonds with hydrogen atoms, they are doing they are attaining tetrahedral structure. Next thing would be there is presence of an oxygen atom and the water. In this case, since these lone pairs are going to interrupt with the bonding of hydrogen atom, they are going to disturb this thing, they are going to disturb this thing. Due to presence of this movement or disturbance of the lone pairs, uh, carbon will attain, I mean, like shape of water will be slightly changed, and this will be termed as bending shape. Okay, so far we have learned covalent bonding. What covalent bonding is, that is simply transformation of I mean like sharing of electron from positively charged group. I mean like sharing of electron from most electronegative element to the least electronegative element. This transformation is going to transform electron from the thing that was comparatively least electronegative to one that was most electronegative in comparison to that element. So by doing this thing, we have learned three to four examples, and yeah, that's it.